Vanakkam, I am Krishna Kumar, Department of Mathematics. The last three videos we have seen the November 2020 CSIR question paper. Already we have discussed three problems. Part C, two problem. Part B, one problem. Now the part B. So very easy question. This question asked the very recent one, 30/11/2020. Tamil Nadu and Pondicherry. So question is, find the last two-digit number of 3 power 2019. These type of question asked in several competitive examination. Is it right? Okay. Find the last two-digit number of 3 power 2019. So four options are given: 27, 37, 57 and last 67. So we are going to find which one is the last two digit of this number, 3 power 2019. Okay. So these type of questions very easy using this Euler's theorem. We know this Euler's theorem. Already we have studied about this. A power pi n. This Euler function is congruent to 1 mod n. This is very important result. Please note down this. A power pi n congruent to 1 mod n. When it is possible, if GCD of which one? A and n should be 1. That is very important. So if GCD A comma 1, then we can use this one. Okay, fine. So what is our aim? To find the last two digit of this number. Is it right? So to find 3 power 2019 mod 100. Why we are using mod 100? Because we have to find our last two digits. Suppose in case one digit means it is enough to find 3 power 2019 mod 10 is enough. Suppose asking last 3 digit. So what do we do? 3 power 2019 mod 1000. So is it right? So depending upon this modulus concept. So mod 100 to find the last two digits. Mod 10 to find the first digit. So this is a proper method to find the last digits. Okay. We get the exact answer. So we have to find out this. So for that I am going to first. So what is the A here as per this theorem? A power pi n congruent 1 mod n. Actually here 3 A mod n value. What is the n value? 100. Okay. So but A power pi n. But we are having 2019 only. It is not pi of 100 2019. Is it right? So for that this can be written as 3 power 2019 can be written as 3 power 2000 into 3 power 19. So our aim is to get pi of 100. So first we should find out the pi of 100 value. 100 can be written as the multiple of prime powers, 2 square into 5 square. So this is a procedure to find the pi of 100 value. We know all about this one. So 100 into, this is a prime power 2. So 1 minus 1 by 2. Then 1 minus is a prime power 5 power 2. So we take 2 and 5. So 100 into 1 minus 1 by P, 1 minus 1 by Q, 1 minus 1 by R. That is the general form. But here we are getting 1 minus 1 by 2 into 1 minus 1 by 5. So after a simplification, so this is you know very well. So no need to explain. So finally we are getting after simplification 40. So pi of 100 40. Then only you can apply this result immediately 1. So our aim is to reduce the value because we are having 3 power 2019 is a very big one, large value. Is right. So using this you can reduce that. For that 3 power 2000 can be written as 3 power 40 then into 40. Is it right? Now you can take mod 100 on both sides. Is it right? So please note down this. So what is a pi of n? Almost we know pi of n is a Euler function which is a non-negative integers which is less than n, relatively prime to n. So that is the definition of the Euler function pi of n. So okay, next now we have 3 power 40 mod 101 because of this Euler theorem, that is a power pi n. So what is the n here? 100. Is it right? 300 a n. So what is the GCD of 3, 100? 1. Then only applicable we are use this Euler's theorem. Is it right? GCD a comma n 1. Then only you can apply. So for what purpose we are applying? Because a power pi n congruent to 1. So our aim is to reduce this value. Then only easy to find the last 2 digits. Is it right? So 3 power 40 congruent to 1 mod 100. Immediately you can write by the theorem of Euler's. Now 3 power 2019 mod 100. Actually we have to find out this which is congruent to, which is equivalent to this one actually. So this can be written as 3 power 40 mod 100 whole power 50. Am I right? So according to the mod property I am applying here 3 power both sides I am going to apply the mod 100. Here also mod 100. 3 power 2019 mod 100. 3 power 40 mod 100 whole power 50. Then 3 power 19 mod 100. Is it right? Okay, fine. So 3 power 40 mod 100 power 50. 3 power 19 mod 100. Just now you have seen. Now what is the value of this? Already we found 1. So 1 power 50 becomes 1. So what is the remaining thing? 3 power 19 mod 100. Is it right? So now almost reduced. Is it right? 3 power 2019 becomes now 3 power 19. So very useful for this the reduced value using this Euler theorem. Am I right? So whatever it is question, they are asking the last digit and the last 2 digit, last 3 digit, we are using that one. Okay, very easy one. Then next, so what do we do? Again we have to reduce this one. So for that 3 power 19 can be written as 3 power 18 into 3. We know this one, everyone. And then this can be written as 3 power 18 can be written as 3 power 6 whole power 3. Is it right? 3 power 6 whole power 3 into 3 mod 100. Then 1 we have to find out 3 power 6. That is easy one, no problem. 3 into 3 into 3. Is it right? 3 power 6, 3 into 3 into 3 into 3 into 3. Easy to find out. We are getting immediately fastly. We are getting the value 729. So that is no way because. Okay. Now 729. We know very well. So this is a divisor, this is a remainder. So remainder value is always less than or equal to divisor value. So for that 729 divides 100. So what is the remaining? We have to see. 7 into 100, so 700. So what is the remaining? 29. So instead of this we are using 29 power 3. So we know that Euclidean division algorithm. Already we have studied Euclidean division algorithm. So using that that's all. Okay. So this 3 power 6 power 3 becomes this 3 power 6 value is 729. So this value should be less than 100. So for that we are going to divide 729 by 100. So remainder value we have to write here as the rule. That is Euclidean division. Euclidean. Then so we are getting 29 power 3 into 3 mod 100. Then immediately we have to find out, very easy step actually, 29 power 3, that is 29 into 29, 29. So what we are getting the value? 24,389. Is it right? So this value also, when compared to 100, so which one is a big one? So for that we have to divide this one by 100. So what is the remainder finally we are getting? 89. So instead of this we can write as per the congruent rule, 89 into 3 mod 100. Then multiply these two. We are getting the final answer now, 89 into 3. Finally we are getting 267. Is it right? Again we use, so it should be less than 100, but here 267. So again using that one, 267 mod 100, that is 267 so divisible by 100. So what we are getting? 2 into 100, 200. So what is the remainder? 67. So this is the last 2-digit number of this, that is the last 2-digit number of 3 power 2019. So we have to practice. So practice is very important. Before that concept we should know about that. So hereafter so we have to follow this method to find the last 1-digit, 2-digit. In this question we are using this theorem. This is very important. That is Euler's theorem, very useful for to solve this problem, to reduce the value. Then only you can find out the last digits. Okay. Thank you very much for watching the full video and with your support also. Nandri.